Exponential functions. In previous videos, we've explored exponent laws. If b and c are positive and x and y are real numbers, then the following laws hold. B to the x times b to the y is equal to b to the x plus y. B to the x divided by b to the y is b to the x minus y. 1 over b to the x is equal to b to the negative x. B to the 0 is 1. B to the x to the power of y is b to the x times y. bc to the power of x is b to the x times c to the x. And b over c to the power of x is b to the x over c to the x. For the exponential function f of x equals ab to the x, both a and b play a crucial role. The role of a, f of 0 is equal to a, so a is the y-intercept of the graph. The role of b, well, if x increases by 1, f of x is multiplied by b. If x increases by 2, f of x is multiplied by b squared. So if we carry that on, then if x increases by delta x, f of x is multiplied by b to the delta x. So let's take a look at the table of values and the associated graph on the right. So if we look at where x equals 0, we see that y is equal to 3. If we move 1 unit to the right, that coordinate doubles to 6. And if we move 1 point to the right again, the value doubles to 12. So as a result, the curve becomes dramatically steeper as the value of x increases. This is a phenomenon that we call exponential growth. Here's an example. One of these functions is exponential and the other is linear. Which is which? Let's start by looking at f. As we increase x by 1, f increases by 4 each time, going from -7 to -3 to 1 to 5 to 9, each time increasing by 4 units. As we increase x, however, g triples each time. 2 over 9 to 2 over 3 to 2 to 6 to 18. So as a result, f is going to be linear and g is going to be exponential. And we can see that on the graph. The blue line is f, a linear function, and the pink line is g, an exponential function. If we want to come up with equations for these, for f, since we increase by 4 each time, our slope is going to be 4. And because when y equals 0, when x equals 0, y is equal to 1, our b value is 1. So we have 4x plus 1. Similarly, when x is equal to 0, g of x is equal to 2. So our a value is 2. And because we triple each time, our b value is 3. Here's another example. If $2,000 is invested in a mutual fund with an annual yield of 12.6% and the earnings are reinvested each month, then the future value after t years is a of t equals p times 1 plus r over m to the power of mt, where r is the rate, m the number of compounds, and t is the number of years. So plugging in what we've got, we have 2,000 times 1 plus 0.126 over 12 to the power of 12 times the number of years. So we've got an exponential equation of the form 2,000 times 1.0105 to the power of 12t. So here a equals 2,000 and b equals 1.010512. The number e is an important number in mathematics. Similar to pi, it's a constant that shows up all the time. It's an irrational number, and so the decimal expansion never terminates nor repeats. It's roughly 2.718281828845, etc. We get this number when we take m very large in the expression 1 plus 1 over m to the power of m. Here's an example. If $P is invested at an annual interest rate R compounded continuously, the accumulated amount after T years is A of T equals our principal times E to the power of RT. So if we want to do this with numbers, if $100 is invested in an account that bears 15% interest compounded continuously, then at the end of 10 years, we'll have A of 10, which is 100 times E to the power of 0.15 times 10, or $448.17.